to make sure that you understand what I want you to do with this. Okay, let's. Okay, so see what's on the picture? You've all seen these kind of cars, right, with a bunch of bumper stickers on them?
Yeah.
Now, I wanted you to think, if you were making a bumper sticker about the most important thing from your reading that you did, what would it say? Okay? So, it could be something that you kind of actually make a little bit humorous, you know, like some bumper stickers are kind of funny. But at the same time, I would say just think about what's the most important message out of your whole reading selection. On bumper stickers, I guess. I don't know. I can't think of a better title for our list. And I'll put period 4. You want to start us out, Josh?
Vibration equals sound.
Ooh. Vibration. Did you say vibration or vibrations?
Vibration.
With an S?
Yeah.
Okay. Vibrations equal sound. What do you think? If you're, I'm going to just say, if you're some scientist that that was your life, that's what you did, you studied sound, do you maybe find that funny and buy it at a gift shop for scientists?
Sure.
Yeah. All right. Well, we'll have to compare to some others. Other ones you guys want to share? Sound is heard in pitches. Any punctuation there? No? All right. Other ones you want to share? Wesley?
Mine has a little picture of a deer.
Okay. I'll try to. I know this is probably not a good ear, but does that look like an ear?
Yeah.
Okay.
It says, I'm gonna go catch some waves.
Oh. Let's see. Go catch some waves. I'll put some quotes around that. Nice. Other ones that people would like to share? Yeah.
I don't know, it's running on soundtrack.
Say that again.
Running on soundtrack.
Say it again. I don't know.
Running on soundtrack.
Running on soundtrack? What do you mean by that? I'm just curious.
I don't think we're on like soundtrack.
Did your reading say something about soundtracks?
Sound.
What is a soundtrack? What do you mean by a soundtrack? I know we use that word around sound, especially like music. Soundtracks. That's something we should think about. Okay. Any other last additions? We've got 1, 2, 3, 4. 4 out of 24. How many? Huh? Oh, there.
Sound travels by waves, but the waves are actually waves.
Sound travels by waves. And then what was the other part?
No, the wave, like, it's not the word wave, it's like actually waves.
Oh, you put the...
Yeah.
Okay. Like this?
Yep.
Alright. Other ones? What's that? Thank you. Going once? Going twice? Now I'm hoping that other people had ones and they just aren't feeling like sharing them. Don't feel like that you would be out-competed by some of these. Alright, so this would be kind of a neat idea to maybe put some of these up around. Maybe we could, with all the classes, have a bumper sticker board. Maybe people would add if it was anonymous as to what they're... Turn to this page and it says Part 2 Directions, okay? This is in your packet that you took home last night. Okay, follow with me as I read the directions right here. It says, next you'll work with people from other groups and combine your areas of expertise to start explaining 3 big ideas about sound. when you combine your expertise, you should be able to start building answers to the following questions. Okay? One thing you're not going to do, you're not going to get up and go to another group. What I already did was I mixed the readings up so you could stay in your groups. Notice why you have white, yellow, pink. You'll stay at your table groups, okay? So, these are the three areas: how things make sound, how sound travels, how sound has different qualities, okay? Those three ideas are going to have sets of questions underneath them that you and your group answer, okay? These questions aren't going to be answerable by one individual person, okay? Because you only have part of the picture, okay? You only have one part of the information needed for these questions. That's where the discussion's going to come in, right? So, can I use you guys as my example? You don't have to do much. I just have to point to you. Is that all right? All right, I hear too sure. You don't have to tell me what your notes are now. Okay, so they're turned to their second page, and let's start with this. Allison, will you read the first question in this first column?
How do you think like instrument words make sound?
Okay, she's going to ask that to her group. And maybe she could follow up with, Tyler, did you read anything from your reading that helps us out with that question? And he's going to say, no, I didn't. I just saw him nodding. And then Kajua is going to say, well, I think something in my reading said that. And she might even flip to her notes and see what she wrote. Or she might actually flip back to somewhere where she was reading and she remembers seeing that word. And then she says, I seem to remember this. And she shares with the group. And then Tyler might be like, no, you've got it all wrong. And then he throws out his idea finally. He was just holding on to it. And then you guys wrestle with the idea. And then, turning to this sheet,
Who's the winner?
well, hopefully you're all winners. And your ideas come together to get out here on the scoreboard. We call this the scoreboard, I guess. So, notice the column title, how things make sound. They would, once they decide on the answer to that first question, they would write out what they decided. You have one sheet per group. Names of the group members go here, along with today's date. Okay? Now, does that seem doable?
Instruments and tuning forks make sound through vibration.
Okay. Was everyone okay with that?
Yeah.
Okay, so you're on down here. How do they make sounds with different pitches?
Or no.
Okay, or no. So who remembers seeing the word pitch in their reading?
Pitch and frequency.
Okay. Now, did you have a pitch or frequency? Because there's a lot of overlap in your readings. All three of you might have actually had.
Because I know, like, how I play the trumpet, the only way that I do pitches and notes is by pressing down different vowels and breathing different, closing my jaw or opening my jaw.
I bet you the stuff's in my reading.
Okay.
Okay.
So, in scientific terms, what ends up happening there with like this? People were talking about sound waves yesterday and how
Yeah, 'cause that's what I got.
sound happens. Now,
How fast an object, how fast the air vibrates.
air vibrates.
Yeah.
Do you think that that's one of the things
Or-
that affects it?
How much
Or how much
air.
force you put in it. Because if you hit it, a pitching fork, if you hit it soft, it'll go to a lower vibration, so it'll give you a slower pitch.
Let me get some. Let's try that. You're saying that if we hit it the same fork, right? If we hit it hard versus soft, you're thinking different sounds. Okay, so let's try it. I'm gonna do the hitting. Okay. Okay. So let's try to remember what that sounds like.
What is a G or
C.
It's
Now,
the same.
what's the same?
The pitch.
The pitch.
It's how much, in like a tuning fork, it's how much of it like moves back and forth.
Okay.
How
So.
much force it's putting out. Or something.
Okay, so when we're talking about pitch, what does that word pitch refer to? Let's first just try to scan through and see who
Like
has
a
information about
note.
that.
I got notes.
You've got no. Oh look, there's some on pitch. I see the word pitch. Does yours have anything about pitch?
Mine keep on talking about the waves and the vibration.
Okay, so I'm gonna have to come to you, okay? Why don't we do this? Why don't you go ahead and look through here and maybe you can read out this section that has to do with pitch. And you can talk about it and decide, was it, when I hit this different, one thing could be changing its volume, another thing could be pitch. If we say it's C,
Wouldn't it vibrate through your ear, making it?
Okay. So
I'm gonna leave you guys with
now
this
you're
one
trying to find a pitch.
Alright,
So pitch
so
is linear perception.
maybe Tyler can do a little reading out loud about this, and
Pitch
then
gets
you guys
higher
can decide based on that.
as
Alright?
frequency of the sound waves increases.
You might be
So,
familiar with the music scale.
The pitch
Do,
can
re, mi,
change.
fa, sol, la, ti, do.
The pitch changes.
Any questions on it? Now you guys have a complete set of colors, white, pink, and yellow. It's a little bit bigger group. Yeah, I mean, with more ideas, it should be easier, and you guys discuss it, and it should be.
From vibration to ear.
It should be in this one. Shouldn't it? Yeah, it should be in this one.
From vibrations in the air.
You might all have a little bit of.
Oh, you know, every time you hear a sound, your ear jump, it vibrates.
Okay.
I learned that in like 2nd grade.
Did you learn anything more about that last night? In that?
No, I don't know. I didn't read that. I just read it. And then, yeah.
Okay, well, I appreciate you being honest with me. But there is more depth in there.
That's what they told me. They said every time, like, even if you clap by your ear, it vibrates. Or when somebody talks to you.
What's vibrating?
Yeah.
They
How
told
about
us.
this? What's vibrating on the eardrum?
Vibrations.
I don't know,
the air.
sound wave.
The air. The air right here is vibrating?
Yeah, particularly. Yeah.
What do you guys think? What are these little things?
Molecules.
Molecules of air?
No, it's from.
It says it pulse.
What?
It says it right here.
What does?
Exactly what
It says those air particles in turn. So I think that's what they're talking about there. And they carry the what?
Carrying the pulse of the vibration.
Now when that bell hits those, what do you guys imagine that those things do?
Each other's moving around.
Hit each other? Move around?
Like how they show number 2.
What is sound?
Okay, but
Okay. Did you guys get to see this? They were just talking about the particles, what happens when they get hit by something. This one has a, you should show Cheyenne, because I don't think she can see that same image in hers. The little particles in the air when the tuning fork hits up against it. Does that seem reasonable that that would happen?
yeah.
What if there were a bunch of ping pong balls around the tuning fork when it was working?
That'd be thought of it, but
That'd be kind of like that, right?
I think we do that with rice. Should do that.
Okay. It says, how do they make sounds with different pitches? I get that. It's like, so how does the pitches change? Because I mean, I know what a pitch is and know what a frequency is. I can put it together, and I can get that the pitch changes when the wavelengths pass the point faster.
Okay.
And the pitch increases. Okay, got that. But what do you mean? How do they make sounds? I don't know if I'm just not comprehending the question.
Okay. So how do they, the instruments, whatever
Okay.
kind, make sounds with different intensities, or you're talking about this one? Oh, this one. How do they make sounds with different pitches? Okay, so I think I would go back to what's the instrument actually doing to the air or whatever that makes it sound different. Let's go with this as an example, okay?
Okay.
Remember how these sound different?
Uh-huh.
Right? So, why is it, let's see, I think this would work. Would you agree that these have different pitches or sounds? Let's listen to it, okay?
They have different. The one on the right is higher.
This one? Yeah. So, they're higher, and we were calling that pitch yesterday. Now, what did it say was the difference? The actual, what is it? What is the pitch? What's the difference between pitches? What does that mean in here? they were saying pitch is the.
Human perception of frequency sound waves. That's all the human.
Okay, so how we hear it. Pitch is like what we think about it.
Okay.
Now they were saying something about the frequency of sound. What do they mean frequency of sound? Is there?
Some
Like, an animal,
sound waves there are the higher
Like-
pitch.
they might hear it different than
Okay, maybe. One of the things I was thinking is just that with frequency, what are they meaning when they say the word frequency? Does it talk about it in your reading? Back a page?
That's
Oh, there it is. It's a measure of.
how many wavelengths pass a particular
How
point
did
per
they make
second.
sound?
I get that. It's just saying how many wavelengths go, past a certain place, like past your ear or whatever
Okay.
per second.
So
I get that.
let's go this. A high frequency would sound like what versus a low frequency? Different sounds?
Yeah.
Can you think of which would you say has a high frequency?
No, because I don't like it. I can make
This
it
one?
It's a
louder.
higher pitch.
Higher pitch, higher frequency? Okay. So what do you think this thing is doing to make that
How much
pitch
air
different?
you move?
Like, think about the way these act differently.
Okay.
Let's take a more extreme example.
How much air
Confuse me even more.
put in your mouth
Yeah.
or object moves?
I don't think you guys got to see this one. But this one, look how long it is, right? Watch it whenever I strike it.
Not as loud
Look
as
at the things. Can you see anything? You noticing anything?
Yeah, the
Vibrating like really
It's vibrating,
fast.
okay. So let's look at this one.
Wow. She's writing it down already on the.
Doesn't
Can you
show
see it?
as much.
I
It
said
doesn't
by
show it
the
as much. So what do you think that means?
amount of air.
Is it vibrating faster or slower?
Us or an
Let's try this. You remember the paper thing?
Whoa, I'm confused.
I hate this.
Well, sometimes you hate things that are difficult.
air. You or an object.
I hated that.
Okay.
Okay,
Now,
quiet, dude. Come on. Give me that thing so we can figure this out.
You
Okay,
or
so-
an object.
which one sounds like it's vibrating faster?
The next one.
Let's try it again.
The one that doesn't show us much.
Whoa, I wouldn't
How
hit
does sound travel from an instrument or to
So in other words, which one sounds like it's hitting the paper slower? Back.
sound another sound wave or
I thought it sounded that way. What do you think?
The,
Okay, so which one's lower pitch or lower frequency?
Them to
Okay,
to go
so
over here.
what's it doing to make that sound?
vibrating slower.
And
No,
The other instrument.
particles?
that sound like
Wait,
words?
so how do you
Softly,
are you just comparing it to a random instrument? Or are we actually using a tuning fork as
We're
an
just
example?
talking about sound, and this is our instrument.
Okay, so you're saying like the instrument itself vibrates.
I went through that last
Okay, so like you're saying an instrument vibrates slower or faster to create different
I do
pitches?
this every year.
You just said that. That's what I think that you're supposed to think.
Got you. Okay,
Got it.
got it.
Awesome.
Thank you. Okay. So is that good with everybody?
It is.
I heard a lot of big words yesterday, and I said, "What's that mean?" Not just Tyler. They're like, "I don't know. I just know that word from somewhere." Which one's it? I'm thinking which question were you guys
You
on?
were on the first or the second column.
The second one on the second column. What is sound, or how does sound travel from an instrument?
How does sound travel from an instrument? Oh,
Or
to a
tuning-
listener,
To a
not
listener.
to
Oh.
the ear. Oh,
So we're talking before the ear or after the ear?
Before.
Before the ear. So between this and the ear, right? What's going on between there? So we're not to the cochlea
air
yet.
particles are bouncing
To wave
towards
the
you.
sound waves into the hearing.
They're like hitting each other and bouncing towards the ear and vibrating. Like those like little things that weren't like going like that.
Did you read something that told you that? Or did you read because you had something that told you about how the sound was going through the
Through the waves I do.
Or through objects.
or through objects?
Imagine you're listening
Oh, look.
I did that in science last year.
This person, Allison, is becoming an expert on waves of energy moving through something. Okay.
I said
this
I had
one was understand. What was that one?
catching sound waves.
Okay. So the nature of waves.
It says it back here. Where was it at? I was just reading it.
Now I think you
Sound
guys
waves also can travel through other mediums such as water, the particles, or these mediums also are pushed together and move apart as the sound waves travel through them. Then a sound wave reaches your ear. It causes your eardrum to vibrate. So basically that's it.
Okay, so that's just telling us that it can happen, right? Through different things. It's not telling us how.
It says it vibrates.
Yeah, and also particles.
Pushing particles.
What
Yeah,
vibrates?
also are pushed together and moved apart as the sound waves travel through them.
Okay, so you're telling me now particles do what? Air particles?
They push together and pull apart.
And that's
Through the
what?
sound waves.
Vibrating. Vibration.
Okay, and then that's the sound wave? I'm just,
That's the sound wave moving through objects.
so give me an example. Let's do something we can see. If I do this, how is that sound getting to you?
You can't see it,
Based
but
on what you're saying.
I
then.
can't see it.
No, just imagine we can see that. I ring this. Okay, pretend it's still ringing. What's it doing to the air around it?
it's pushing the air towards
The person
or away from the object.
Okay,
Towards
I
the-
remember when I was looking at these earlier, there was some sort of diagram that showed a tuning fork. You guys remember seeing that?
There.
Yeah. Let's look at that and see if that helps you think about how the sound is going. And I'm going to leave you guys with that, okay?
Elevation source like produce compression.
Like if I have my car in the middle, right? As the waves travel away from the source,
Other these compressions are from a sound wave.
That's showing it when
When
it's
it
pushing
hits
against
there.
first pushing against the air, it compresses it,
And then it'll
and that compression of particles is moving away from it.
Yeah, but then it'll reflection. So basically, produces compression and reflections.
No.
Yeah, because that's what you just said right here.
the waves
That's not
are
reflection.
closer.
Well, because they're on this it's showing that it's got certain sections like this separated together, so it's like phasing in and out.
Yeah, it's phasing in and then sometimes it phases out.
Okay.
You see what I mean?
So it's not one continuous all the time.
Not all the time, but most of the time.
Well, because it fades.
It fades. It fades in and then it fades
Yeah.
out.
Alright, so now for
Number, which one?
How does sound travel?
How does sound travel from instrument to instrument?
Okay, go ahead. So,
Supposed to turn it like a wave.
type of wave.
See they traveling?
Okay. Okay, so
How do things like instruments and tuning forks make sound? Wouldn't that be waves or is that me?
well, what did you have?
I had sound waves and stuff.
I have the ear and
Yeah,
pitch and frequency.
So
and
she can have how sound travels, right? Yeah,
how
that'd be.
sound has different qualities.
Yeah, but got the parts of a wave. Wave properties. That's what I have.
Well, the first section I got was how the ear works.
What section are you, 3? Oh, this is gonna be me right here. Okay, this is gonna be me.
Number 2, how sound travels.
Yep.
So then you have the first column.
Who, me?
This is him and this is me.
What is yours?
Waves, like sound waves. Yeah, dude, I read everything about sound waves.
Karen's gonna come join your
Waves and
today.
energy.
We're short that white paper, so she's gonna be come up here. Hey, Karen, I'll grab you a chair so you can see.
What did you do? You just
Ooh, slinkies. I just noticed those.
Yeah, I don't have anything for.
Why it travels.
Well, maybe I have the first one too.
I don't have anything.
Leticia.
Yes, I can. No.
That would help.
Yeah, 'cause frequency, and then I
Yeah,
have
is that in the yellow packet? How things make sound?
the frequency and then the pitch and frequency and all the other beautiful words. The hertz, ultrasonic, infrasonic.
I think I might have the qualities. I don't know though, I didn't really.
But I don't think this splits up into like.
Yeah, I don't
That's
think
your
it fits
section.
the packets.
I think it's just like everywhere.
Yeah. How does sound travel from an instrument or tuning fork to a listener? That's probably those of you guys, the waves.
Because we didn't have waves really.
Yeah, I think that one's
We
yours
just had
too.
the
Yeah,
C and
how
R
it is.
words. Not call it that. Impressions and stuff right there. Together, loose, together.
I've got amplitude if that helps.
What? We got so many words on this packet, right?
Oh gosh.
I think this one might be yours.
Decibel.
This one might be yours right here. To be a listener, right? And you had
No,
the
that's
ear.
no. I can't be. That should be you because that's the waves that travel through the air.
Yeah, wait. What kind
Yeah,
of waves do
pretty
you
much.
have?
I've got
Maybe that's
transverse and C something.
Because you got what is a wave?
Yeah, me too. I got
What is a
wave and medium.
Parts of a wave.
See. What is sound? Yeah, I got that. An object produces sound when it vibrates and
This is
matter.
like a college package.
Why?
Little print. Ours is like from textbooks.
Yeah, no.
I got the textbook one too in the back right here.
No, that's not. Oh, there's your textbook.
Yeah, and then I got this extra one right here.
Well, you got a lot of stuff.
I got that too.
Oh, we got two
I
that
don't.
vibrate.
Look,
No, but
I
it
got all
actually
of
helps because in the packet it doesn't say the words. Like in the chapter book, we don't know what it is. Air particles that collide.
Section 1, what is sound?
Air particles that go back and forth. Catching sound waves. I know how to catch sound waves. It's a funny word to say.
What is?
Peanut. So your ear right here, all the structures. That's how you catch waves, all of this.
Peanut.
Yes, that's how you say it. Or the outer ear.
Yes.
This is the ear canal.
Wait, do you have like seismic waves and stuff on yours and water waves, like what they are?
I like the water waves, yeah.
Yeah, but mine just says. So yours
Oh, here
is for
goes
mine.
sound waves right
A
here.
little torture.
Yeah, no, this is section 1, yours is section 2.
I can't say that one yet.
But sound waves.
And then it goes through that one too. To your brain that it transferred into, like, yeah. It goes through that and then it goes to your nerves, to your brain, which it translates into.
Is there any questions
I've read
about
it
the
so many
ears?
times.
How many times did you read this?
3 times?
The whole thing?
Yes. That's why I got a lot of notes. I just kept on reading it. When I was taking the notes, I was reading it again. So that kind
The question and answer.
Sound waves.
What is sound? Does anyone have
well, can we
that?
answer this?
I think that might be mine.
Yeah, I just told you that. It's vibrations that matter.
You got sound?
Yeah. Oh, you're looking for it?
Yeah. That's what I was looking for.
What is sound?
Yeah. I was actually looking for that exact
She
one.
gave the answer.
What's this?
It's right here, dude. An object produces sound when it vibrates and matter.
Wait, that's how something makes sound though. How does sound
That is
travel?
sound.
That is sound though.
But what is sound? Sound waves are...
No, that's
Pressure
sound
waves.
waves. So that's sound
Oh,
waves.
okay,
Not
okay.
the typical sound.
The waves are in the sound isn't at itself. No.
Look, look, it says, to understand how your ears hear sound, you first need to understand what sound is.
Don't we have to
And
do
it
the
says,
questions in order or it won't make sense?
An object produces sound when it vibrates in matter. This could be a solid,
Should I put that?
liquid, or gas.
Should I put that?
Well, yeah, but like,
It has to be matter. It doesn't have to be solid, liquid, or gas. And it produces sound. You don't have to say an object produces sound. You can just say an object creates sound when it vibrates.
I'll put in
in
my
matter.
own words?
Yes.
Ah,
Yeah.
I see.
That's what I did with notes.
Create sound when...
An object creates sound when it vibrates in matter. It could be
alright,
solid,
Alex, I
liquid,
know
or
this
gas.
question's yours right here. Does sound travel differently?
Well, like,
I'm just curious what you guys have done with the Slinky so far.
what has?
How about this? Did you guys simulate a sound wave with the Slinky?
Yeah.
Okay. So, you know, let's think back to the tuning forks, right?
Yeah.
When we had 2 different tuning forks, we had a small one and a long one, okay? What did the small one sound like compared to the long one?
High pitch. Yeah.
Pretty high, right? Okay, so what made it high pitched in terms of sound? What were you thinking is the difference between like a high pitched sound when you think about what the sound is versus the low one?
Swear to God. Go look it up. Put 8 on your dictionary.
Oh.
In there.
You know, like what makes a sound low versus a sound high? Like, with the tuning forks, what made the difference?
The size.
The size made the difference, right?
Yeah.
But what did the size have to, what did the size affect?
Well, the frequency of the vibration affected the sound.
Okay, so how did it, you said frequency and then you said vibration?
Yeah.
What do you mean with the vibration? How did it affect the vibration?
Because since when you move, the tuning fork vibrated faster, making it higher pitch.
Okay, you're saying the small one vibrated faster?
Yeah.
Okay, so would you be able to show with the Slinky like what a high-pitched noise sounds like? Or not what a high-pitched noise sounds like, but what a high-pitched noise looks like?
Oh yeah. It's kind of like fast.
Fast?
Yeah.
Okay. So I'm curious now, if you were to think about, could you have a high-pitched loud noise? Oh, okay, so show me that. Okay, so that's high-pitched, you're saying. Okay, now what if you turned up the volume on that? What would you be doing? If you're making something louder, what would it look like? What do you think?
Yeah, I think so.
Well, faster you were saying would make it what?
It has to get more energy.
Hey, you know how they have in the control room? Like you
I
play
think
music,
that-
like those little squares going up and
Right
down?
here, that inside the way.
What were you saying, Jose? Something about energy?
Yeah, I think it has to carry more energy
To do what?
to sound louder.
To sound louder. Okay, so say we're going with a high-pitched sound. How would you show that it has more energy?
Like a bigger.
So we're in a set speed, but what do you think would be different than not making it loud? You said more energy.
Looks like pottery. What's the third question?
So basically,
More vibrations would be what? Make it higher pitch, right? So what if we just wanted to change the volume and we wanted to keep the same tone? Do you have any ideas, John?
You know what the wave means?
With the same frequency.
So you're saying keep it the same speed, but how would you make it a stronger vibration?
That's wave, like
With the Slinky, let's pretend Slinky.
Alright, write this down. Write this down because I'm only gonna say it once.
Okay, I noticed one thing that you changed. You changed into a, what kind of wave? Remember the name of that wave? Starts with a T.
I said I was only
Transverse.
Yeah, that's a transverse wave. Now, do you know what travels in that kind of a wave? What kind of, or what, sorry, not what travels in that kind of wave? It's energy, but what, they had an example in the book of stuff that moves. Certain mediums can have that kind of wave in them. Do you know any waves that occur in nature that look like that?
Oh yeah, the waves in the ocean.
Yeah, waves in the ocean. Okay. What are the waves just in general and sound look like with the Slinky?
I don't even know because I was asking today. The first day.
Well, a second ago you were showing me this. Which one are you
We
thinking?
have to do a power song.
Oh, then I should, I think like that, right?
Did you remember seeing this thing in here? I think it showed a tuning fork. Was it this one? I think it was back here. Yeah, tuning fork. Now, that's what the tuning fork is doing to the air. And then there was something on the next page. Yeah. So, by looking at that, what do you guys think that thing looks like? Does it look more like a wave like this? Or does it look like the thing you guys were doing before?
Actually, mine was this one.
Like a strong one.
I'm gonna send a post to it. Stop. Don't worry.
So I think they were talking about amplitude and energy there.
Yeah.
I think that will show you and confirm what you're thinking about with volume or amount of energy. Or what it would help with.
Oh, it keeps getting tangled.
Yeah.
Because look at this, are those, is the spacing there pretty much the same?
Yeah.
Okay, so what would that mean about its pitch?
That it's the same pitch.
Okay.
About the same.
So how would we make our slinky look more tight in between?
I can't answer the first space.
Just try some things
Faster?
out.
Instead of like that.
I was gonna see how it stays
Right, I
together.
can
It like stays together apart.
So I see you using like more force. Could you still move fast but use more force? Yeah, just keep do that, but do it harder.
That is amazing.
Can you see it, the wave traveling through there?
Yeah.
And if you notice there's it keeps you'll see a pattern starting to go like this. Which did it look tighter in? When it was like softer or harder? That little section. When did it look like it was closer together? When you do it like kind of soft, or when you do it harder?
When you do it harder.
I'm gonna leave you guys with that. That seems like I guess we brought up several things with this, and I don't know if you want to take a look back through this and confirm what you guys are thinking about this, and then try with the slinky. Maybe you could do that, and I'll just leave you with that. Okay. How sound traveling? So, okay, guys. If I could have everyone look up front for just a second to make sure we know what we're doing. For the first 15 minutes, I'm going to have you working with the groups you worked with yesterday on finishing up those questions about the big ideas of sound, okay? I'm going to come around and talk to your groups. 15 minutes starting now, so that'll take us up to 1:25? Yeah, 1:25. We'll rein it in, then we'll talk about some of the ideas from the readings and questions. And then we'll go back and kind of revise and change our drawings. The drawings of the instruments, okay? All right?
Vibrations. Do you feel them?
Yep.
So, oh, I got that?
Yeah, that's right.
You detect sound by vibrations?
Yep. By feeling the vibrations instead of hearing them.
Are we done with that one? What did you do? Or usually just three?
Don't do this.
So we're moving on to this one. How do things like instruments and tuning forks make sound?
Instead of
Sound
feeling
waves?
them.
Instead of hearing them.
This guy called us
God, I was gonna correct me.
No.
Okay. So, the next one is, how do things like instruments and tuning...
What you guys doing? You got your stuff?
Yeah.
All right, good. So, you guys got to play with the slinky yesterday, right? At the end of class?
Yeah.
Okay. Thinking back to that, I'm going to ask you something real quick. I want you guys to think about what you envision sound as looking like as it travels, okay, or how it's traveling through the air. And I've got a drawing. So, before you say anything, I want you to think about this for a second. If I asked you, which is a sound wave? Is it more like A, or is it more like B?
B.
B? B too? Okay. Now, do you see any difference along these lines?
Mm-hmm.
Yeah?
Bigger and closer to
Oh, it's funny. I
Bigger.
didn't actually try to do that, but it does have that. But
They're bigger and closer together.
Yeah.
bigger and closer together. Okay. Yeah, I meant to draw them closer together and then spread apart, closer together, spread apart. And what do you picture that closer together and spreading apart? Why that?
Like once you push it, they're gonna be close together, and it's gonna spread back out, be close together as the sound travels through the ring.
Okay. Or how about this? Let's transfer it to air. If this sound was traveling through the air, what's going to be getting closer together and what's going to be spreading apart?
The air that it's hitting is getting closer together, and the higher behind it is spread apart.
So, I'm just curious, so I'm checking in.
Hey,
And,
Mr. Altoid, you got one of those Altoids?
no, do I need one?
No, I just.
Oh, no, I don't. I wish I had one because I feel like I need one too.
They're good.
Yeah, I'm all out. I need no more.
Yeah, she has peppermints, yo.
What's number 3? Start plugging sound channels through the cloud and go the sound.
Or does she got chat lips?
How does that work? Long New York. The less intensity. I never knew
We're doing house sound.
Hey, I was going to ask you guys, yesterday at the end of the period, we used a slinky a little bit at your group. You guys did? Okay. So, based on that, did you guys get to simulate what a sound wave looks like with a slinky? Do you remember that, Teresa? No? Okay, if we had a slinky here, what would you do with it, Teresa? Yeah. Sorry. Me too. I do too. To simulate a sound wave, what kind of actions would you do with your hand? Shake it. Okay. If I brought one over here, could you show me what you're thinking based on yesterday? All right. Let me get one. Because I heard Louise saying something and I heard you saying something too, and I was just kind of curious if you guys are in agreement about what it looks like. Okay, so you're showing me what now? Okay, what are you thinking, Louise?
I'm thinking like
Pretty much agreeing, or? Okay, now how about you show me what you're thinking? We'll see if it's the same or different.
like if you want a high pitch, it'll go faster, so it'll go like this. Sound will travel faster like that, but if it was low pitch, it'll go even slower, like that.
Okay.
So there's different. You can tell there's different movements in sound.
Okay.
Like
based on like
space.
how fast or how slow it's moving through. Okay. Now I would say the wave that you were showing, Teresa, this is more like what you see when energy's traveling through water. But if you have the energy traveling through air, this kind of thing, like Luis was showing, pretty close to what we think is happening there that we can't see.
And how do you know
Now
that?
do this, Teresa. Oh, hold on a sec. Hold this. Okay. Now let's watch this as I watch you push it forward and back. Okay, do it real fast. Okay, remember when we had the tuning forks? That's like the really high one. It's going versus the low one. That's like the low one. That's the high. Show me the low. Yeah. Okay. Yeah, there's tissues in mine. Looks more like a sound wave. The B?
Yeah.
B? Alright. See how those are close together there?
Yeah.
And those are spread apart? In the air, what do you think's close together? And what do you think's getting spread apart? Huh? Air? Oh no, within this one. If you think of, instead of the spring, if you think of the air, what's getting squished together and what's getting spread apart when we hear sound? Is it the sound?
Like the air particles.
So Teresa, he's pointing to these. Those represent the air particles. And I think on here, right here, see that? See those little dots? Read what it says there.
In a high amplitude sound wave, particles are tightly packed in the compressions and far apart in the red spectrum.
Yeah, so the particles they're showing, those are air particles. So, Yeah, so that one looks more like that, right, than this.
In here, how do you like know which is which?
Well, each packet has something to do with all of them. So one packet doesn't just fit with one column. Alright? Yeah,
But the
it's kind of
yellow
mixed.
has the same thing.
Well, they have similar titles in some of them, so maybe that's a good place to start. Alright. How are you doing? You just finished? Alright. Awesome. So, quick check. Don't say anything before you... Okay, how about this? Just look at it and think of the answer to yourself, okay? I'm going to show you something, and I want you to think just like what you're thinking of a sound wave as looking like, if you could see it. Would it be more like A?
Sound?
Yeah, or more like B? Just think about it for a second. Which is... Okay, now tell me what you say. A. B. Okay, so B is one of the ways that you represented a sound wave with a sling. Okay. A is closer to what they were talking about as water waves looking like. If energy transfers through water, it will a lot of times do this. You can transfer this kind of a idea of a wave into this, but if you think about the vibration of a drum, you hit the drum, and you know how the drum head moves back and forth? As it moves back and forth, if we think of this as a drum, and I hit, think about the air on this side. What's it going to be doing? Kind of like compressing back and forth. Or moving back and forth, but it compresses it a little bit. Just keep going. Well, let's take a look here. I guess if you look at the one, I think it's in here, it shows with a tuning fork. What they were talking about when the air first gets hit.
It's a pattern. It's like back and forth, together, tight, loose, loose.
Yeah, it's like compressing, kind of springing back. Compressing, springing back to normal.
But it moves the other one in front of it, so it just goes on and on and on.
Oh.
Until
yeah.
Different sections.
Yeah, like this. With here, we had this, and
one moves the other one and the other.
yeah. If you just hold that in, and then if you push this, you don't really have this part of the slinky moving down there, but that wave of energy, yeah. So push that, and if you give it enough force, have enough energy, it'll travel back. Yeah, now do a series of pulses, but just do them forward and back. Yeah. Now, if you think about the high tuning fork versus the low one, the high pitch one versus the low pitch one, how do you think it would look different in the wave?
Oh, the high pitch one. See as much as the lower pitch would be like that.
Let's take it back to thinking about vibrations. You hit the high pitch fork, did it have fast vibrations or slow ones when you touched it on the paper?
Wait, why do you keep rewriting it for?
I wrote it. We didn't hear the second one, but the first one was the high one.
Yeah.
Oh yeah, you
Okay. Well, I was gonna say. Well, we'll talk about it in just a second. Let me actually let you hear the
That's the same thing I
difference in buzzing. I think you can hear the difference with these. So I'll buzz this one on the paper. Okay, now let's try to compare it.
Faster.
This one is faster?
Yeah.
Okay, so this one, did you think, which one was a higher pitch?
The smaller one.
The smaller one, the faster one. Okay, so being that it was faster vibration, yeah, faster vibrations,
The higher
pitch, and the
waves.
Oh, yeah.
so anyway, we're gonna move on and see, check in a couple other groups. So you guys finished? We'll wrap this up in a second and go on and kind of summarize the ideas. I'll leave that with you. So, can I ask you guys a quick question? I'll wait until Marquez is done. I'm going to ask you guys about what you think a sound wave looks like.
Sound wave looks like a wave,
I've got two choices even.
It doesn't look like this. Remember, does it like the pulse?
The pulse, yeah.
Like the pulse.
So say that again.
It's like a pulse, basically. Like,
Pulse. Yeah.
well, I could demonstrate.
You could show me with that. All right.
Pretty interesting.
I had to remember that part. I was
Like when it's
okay. Soft sound. It goes quick like this.
it goes like soft sound is like light. You see how the thinking moves?
Okay.
And when it's a loud sound, it goes like it's a big one like that. And then
Like when it goes together.
connects together like that, and it goes.
Okay. So when you're saying soft and loud, you're talking like the volume or you know how loud something is. Okay. Now what if something's like low sound, like versus
the frequency.
how is that amount in waves?
When frequency, the higher the frequency, the higher the pitch, and then the lower the frequency, the lower the sound. That's
Okay.
what I remember.
It goes
Yeah.
slower.
Which one goes slower?
The lower boom like that. It goes like this, but the higher goes like this.
Now, does that make sense when you think back to tuning forks? Remember when you hit them and you buzzed them on paper?
Yeah.
Which one sounded like it was moving slower?
The
Short one.
it was the big one.
Yeah.
The little long one.
Yeah,
It
the
was
big one.
like that. It never really got higher. It got louder, but it never got higher.
Okay. Thanks. Low packets. Now, while we got the Slinky out and while he's gone, maybe let's talk about what we'd use a Slinky for. Okay, you could make waves or simulate them, right? Okay. Now, what are you guys thinking, based on the readings and based on what you've heard? What are you thinking next? How about this? How could you show what a sound wave looks like with a Slinky? You think you could show me that?
Right.
Let me move this out from underneath. And Danielle, I want to see if you agree with what they're showing. Okay.
You do. I can't do it this way.
I'm not good. I'm not good at swing.
Do that. You do that. You just pull it back and forth.
Like they either go like sometimes they go like this too.
Okay, so you're saying sometimes like one, and sometimes like what Roberto was doing?
Yeah.
So if that's the case, when is one and when is the other?
I don't know.
Guys, will you go ahead and put that back on the counter?
I don't know. Like there's two different types of waves.
True. Two different types of wave. One is what a sound wave looks like. One is more like what water waves look like.
Yeah.
Okay? So between the pink packet and the white packet, I'm pretty sure that there's some information in here that can help you decide on which one is most like a sound wave.
Which one? What did you say?
Well, I wish I had it. I'll grab my yellow packet because I want to show you something. If you think about this, you think about whenever a drum, when you hit a drum, okay? When the sound is made by a drum, why is that? You hit the drum and then what happens?
It makes a sound like.
But what's the sound coming from the drum? You hit it, but why? How does the sound come from the drum? What's the drum actually do? Vibrations. Okay. Now, when the drum's vibrating, what's it vibrating against? Partly the hand and the stick, but then what's on the other side of the drum? Air. I mean, you don't see anything, but there's air, right? Okay. So when you imagine the air getting vibrated, what would that drum head look like when it's moving back and forth, right? Like this, kind of?
Tingling.
Like what Roberto was doing, right? Roberto, do that movement like this again. Okay? That's what's happening with the air when it's up against that drum head. Water is shown with this kind of wave, more like, or the energy in water travels more like this. So with this, that back and forth, either with the tuning fork or with the drum, it's like that. Now, what if you hit the tuning fork real hard? Okay, you would have more energy. Now, here's one thing I'm thinking. When you tap the tuning fork, did you try? You tried two, right? One sounded. How were they different?
Higher pitch and lower.
Yeah. Higher pitch and lower pitch. Okay. Now, what did you think made one higher than the other? Like what was it? Huh?
The sizes?
Okay, the size. Did you hear how they vibrated on the paper? Did one vibrate differently than another? Okay, so the amount of vibrations has something to do with the pitch, and that would be like the speed he moves his hand. Okay. We'll talk about this in a little while. So one thing to think about is how he moved his hand back and forth is more like a sound wave. I think that it seems like you've got part of that, as far as I can tell, sounds exactly right. Now, you were saying again, you were wondering like what is actual sound, like what is sound itself? What are you thinking, Leah? Throw out your ideas, and we'll have Nina throw out her ideas about like what is actually sound. Not sure. Okay. What would you say, Nina, if you had to?
The waves, it's kind of hard to explain.
I completely agree, because I have difficulty thinking about the answer to that myself. Tyler, what did you guys think whenever you took on that question? What is sound? You don't remember? Did you guys write it down?
None of this paper was on the other.
Oh, that was the one that Allison had. Now, let's go back to how sound might be made, right? We could hit something, like a tuning fork. We could hit a drum. We could pull on a guitar string, right? What do all those three things have in common?
Well,
We hit a drum, we hit a tuning fork, or we pluck a string.
there's a reaction.
There's vibration.
Okay, there's reaction, there's vibrations. Think about the fact that we've kind of put some effort into hitting the drum or pulling on the string. Okay, so in a sense,
So when the wave moves, it basically makes a sound.
the vibration creates a wave, and the wave is carrying energy from one thing to another. So like if you think about, would you say that you have to use some energy to hit a drum?
Yeah.
Okay, so once you hit that drum, is like the energy that you use to hit the drum, is that just gone?
No, it makes sound.
It makes sound.
There's a reaction, which travels through waves.
Okay, so what's the reaction you thinking? Is it, you mean like a reaction to like you
Yeah,
hit
when you
something?
hit it, you see it first and then you hear it.
What is it you're seeing? I'm just curious what you're thinking.
You see it like moving.
I know that.
You see it moving, the drum or the vibration. Okay. Now that's what I really liked about the thinking about the bass and thinking about the tuning fork, is you could actually see that movement.
It says nearby air molecules are pushed together by the vibration.
Okay, and that's what.
And then when they're squeezed together, it makes a concrete something wave.
Oh,
and then it travels through
this
the
word?
air. Yeah.
Compressional.
And then it travels through the air. And when the sound wave reaches your ear, it causes your eardrums to vibrate. Your inner ear then sends signals to your brain, and your brain interrupts. I can't say that word.
The interprets?
Yeah,
interprets.
signals as sound. So is that like the definition of sound? I think that's
I
the
don't know.
closest thing.
That's the closest thing you're getting? Alright, well maybe whenever we discuss these things we can come to a better conclusion, because I want it to be an idea that works for all of us versus just like, something that's in the book.